Hello, everyone. You are welcome to today's lesson. In today's lesson, we are going to continue from where we left off on our lesson calculus, but specifically differentiation, and more specifically, differentiation of implicit functions. Okay, so in our previous meeting, basically we concentrated on how to differentiate functions where our y was not explicit, was not made a subject. Okay, so indirectly we looked at what implicit functions, where you had y not made a subject, or you have terms in x and y, in your given function or relation or equation, if you so put it. Okay, so we are going to continue from there. Remember, in our last meeting again, you realize that all the functions that we differentiated, all the relations that we differentiated, we had a situation where your terms were either in x, or y. Now, if you look at the second worked example that we have before us, you can see that you have some of the terms in both x and y. And we have equal to as well. We dealt with a situation where you have x and y, but there is no equal to, meaning there is only one term, and you are differentiating a term in x and y. And we realized that we said anytime you are differentiating, such a term, such an expression, we have to make use of what? The product rule. So it's the same thing. You realize that when we're dealing with the situation where you have equal to, we said we will take d dx of both sides. And as you are taking d dx of both sides, you end up taking d dx of terms. Some of your terms will be explicit, or yes, in terms of x, or will only be in terms of y, as we saw in our previous examples. But today we will get some of the terms also to be in what? X and y. But I've given you that strong foundation in dealing with that. So it means dealing with the question that we had before, as with just a little input from me, you should be able to come on board, each and every one of you, for us to have a smooth sail. So as usual, stick and stay with me whilst I walk you through the solution to what we have on our screen, the worked example. All right, so as usual, as you read question, we are entreated to make it a habit to underline the salient points, if any. So if you look at what we have here, we are asked to find dy dx, of the following. So it means we are finding dy dx. And I've told you, anytime you are asked to find dy dx, it means you are differentiating, you should know. But anytime you are differentiating, you should know the differential operator. So if you are asked to find dy dx, in this dy dx, what information does that give us about our operator? What do you think our differential operator will be? The entire class.
d dx.
d dx. So remember, so this tells us that we are going to take d dx, of both sides. Because here we have an equal to, and anytime you have an expression, involving an equal to, any of the inequality sign, then it means we have sides, basically. So we are going to take, so as usual, the first thing that you write is solution. After solution, then the major question number, if you have. So there is a major question number, which is question number 2. Then we come to what? A. We extract what we are given first. And what are we giving? It is x squared, plus xy, minus 5, is equal to what? 0. So now at this point, what do? We have to go, is now that we are going to apply, the d dx, on both sides or to both sides. So we are going to have d dx, of what? X squared plus xy, minus 5 is equal to d dx of what? Of 0. So remember, because this information that we extracted, what we are giving involves equal to, you are advised to start with what? The implication sign. Or like I said, better still, you can ignore. But as you are entreated to use that sign, let's use it. So in this case, we know, okay, your operator is affecting three terms. Okay, I mean, the operator to the left-hand side is affecting x squared, xy, then minus 5. So three terms. So that should tell us that we are going to differentiate each of the terms. Okay, so we find a differential of each of the terms. So in that way, we are making use of what? The sum and difference rule. Okay, so on that note, okay, you know, mentally now we are matured looking at where we are coming from. So if you find d dx of x squared, that will give us 2x. Do you agree?
Yes, please.
Okay, so instead of writing d dx of x squared, d dx of xy, okay, d dx of minus 5, you know we are matured. So we can do that mentally. Okay, so now then you come to d dx of xy. And you can see the xy, remember, you are told to treat xy as a product of x and y. So as I'm differentiating, I have to differentiate using the product rule. So that tells me that I'll write plus, come and hold the x, then find d dx of y, which will give us dy dx. Do you agree?
Yes, please.
Okay, so dy dx here. Okay, then plus, you hold the y, then find d dx of what? Of x, which will give us 1. Are we in agreement? Oops. Okay, so sorry. Let me pause, then do the needful. Okay, so now what do we do? We said d dx of x will give us what? 1. So we are going to have 1. Okay, then it will be minus d dx of 5. But you know that the differential of a constant will give us 0. We will write it. So that will be equal to, again, d dx of 0 will give us 0. So we are going to write it here. As for that one, you can't say that you won't choose to. Unless maybe there is another term, then you can ignore the 0 and come and write the term. Okay, is my point well made?
Yes, please.
Okay, so now you know that there is only one bracket here that we have to come and deal with. So I'm going to combine, okay, removing the bracket here and isolating my term in dy dx. Okay, so I'll combine the two. Okay, all right. So if I hold, I'm isolating my term in only one term in dy dx. So that is the x. Okay, dy dx. Okay, and that should be equal to, okay, 2x, okay, that will be negative, so negative 2x. Then this will be y, so minus y. Do you agree?
Yes, please.
Okay, very good. So at this point, you know, okay, we are going to write it again before dividing by what? Our x, because the dy dx must stand alone. That's what we are asked to find. So at that point, I can say that my dy dx, okay, will be equal to, okay, to be this one over x, this one over x. So I'm going to get minus 2x minus y all over x. Are we in agreement?
Yes, please.
Okay, so I can put my therefore here. All correct. Afa, my professors.
Yes, please.
Okay, very good. Okay, so on this note, then we can move on to the B. Okay, so B, I want to hear your voice more. So let's do the B together. So B, what are we giving? We are giving x squared y minus what? 5x. Okay, then is equal to what? 3. So what do we do to both sides?
Find dx
Of both sides. Okay, so I'm hearing only one voice. So, okay, so please d dx, okay, of this side, and because it's more than a term, we are compelled to put that in brackets. Other than that, the meaning changes. Your d dx will affect only the first term. Okay, so it's equal to d dx of this side. Okay, so now let's differentiate this, okay, mentally. So it means we are going to find d dx of this quantity, that is the x squared y, then what? D dx of what? 5x. So that will give us d dx of x squared. We are going to treat s squared y as what? The product of s squared and y. So we need to use the product rule in differentiating. So you hold s squared and come and differentiate what? Y with respect to x. So you find s squared, okay, d dx of y. So that will give us s squared dy dx. Do you agree?
Yes, please.
My professors, is everyone following?
Yes, please.
Okay, all right, then, okay, plus, you come and hold the y, then differentiate s squared. If you differentiate s squared, find ddx of s squared, what do we get?
2x.
2x, so in brackets, okay, 2x, you are doing well. So that will be, keep it up, that will be the differential of s squared y. Okay, now you come to the second term, so it will be minus the differential of 5x. So if you differentiate 5x with respect to x, meaning you are finding ddx of what? 5x, already the minus will be there. What are we going to get?
5.
5. Okay, so you put your 5 there, which is equal to ddx of a constant will give us 0.
0.
Apeke.
Yes, please.
All right. Okay. So now at this point, we are in a comfortable lead. Again, you can see that you have only one term in what? In dy dx. So you have to isolate that term. So in my isolation, I'm going to combine the two, isolation and the removal of the brackets. Okay, you let me remove the brackets here before so that those who, okay, wouldn't be able to follow. But indirectly, I've told you that you can skip that. I mean, you can combine the two. So this will give us 2xy. Do you agree?
Yes, please.
Is equal to 0. So now I'm going to move. So those who are matured can skip this and move to what I'm going to do. You won't lose any marks. Any marks here will be given to you at that particular step as well. So if you miss this, you won't lose marks. So we are going to maintain or isolate the s squared dy dx. Okay, then that will be equal to, you move these two to the side. As you are moving, you know that if you move, this will be negative, this will be positive. So you don't write that negative term first. You have to come and write a positive. So I am matured. I thought before writing. So I know this will give me 5 minus what? 2xy.
Right.
You get the point?
Yes, please.
Okay, so you write it again before you divide by, okay, dy dx. Sorry, you divide by s squared, I should say. So I can say that therefore my dy dx, okay, will be equal to 5 minus 2xy all over s squared. Are we in agreement?
Yes, please.
Okay, so this becomes your dy dx, okay, of what? That function. All correct, my professors.
Yes, please.
Okay, so that will be it for the A and B. Okay, so we have two more to do together. Okay, obviously the one in red, I can't touch it. Most likely it will be your assignment. Then the F equally, most likely you see it in your test. Then, okay, we are left with C and E. Okay, so let's, let me see whether I created another slide for the, okay, so I didn't create a slide. Okay, so let me quickly go and create, okay, another slide for, so quickly. Okay, so now let's go and look at the C. So C, what are we giving? S cube, okay, plus Y cube, okay, is equal to what? XY. Okay, so here, how many terms in Y can you see?
2 terms.
2 terms. So obviously it will tell you that you are going to get, okay, 2 terms in dy dx. So a little more work in terms of your factorization, but basically the same, okay, principle. So what do? We take d dx on both sides. So this implies, okay, d dx of what? Of the left-hand side, which is what? The s cube, okay, plus what? Y cube. And that should be equal to d dx of what? Of the right-hand side, which is what? D dx of what? xy. Okay, so at this point, we are going to take d dx of s cube, and d dx of s cube will give us, let's go.
3x squared.
Do you agree?
Yes, please.
Okay, so 3x squared, very good. I equally agree. Then plus, we are going to find d dx of y cube. That will give us
3y squared. 3y squared.
sure.
3y
No,
squared.
No,
Three.
please. 3y.
Oh, my
Wait.
professors.
3y
No,
squared
no,
over
please.
3y.
squared divided.
3y squared dy dx. Remember, I've told you, anytime you are differentiating and you have a y term, even in my introduction, the steps in differentiating an implicit function, you were told that if your term contains y, you always attach what? Dy dx to, okay, the differential. So it means we are going to get 3y squared, then you attach dy dx. Afa?
Yes, please.
Okay, so it cannot only be the 3y squared without this. If we're finding d dy of what? Of y cubed, then you get the 3y squared without the dy. But here is d dx of y cubed. So you are done with the left-hand side differential. So that would be equal to, so again, you are differentiating xy. We have to use the product. Hold x, differentiate y. So that will give us, if I'm differentiating y because I have y, I'm going to get what? Dy dx, our usual. Is that clear?
Yes, please.
Okay, then plus come and hold the y, then differentiate the x, and that will give you what? 1.
1.
So far.
Yes, please.
Okay, so like I said, here we are going to show maturity at normal circumstances. We need to, the next step is supposed to be you removing the bracket here. Then the next step will be isolating the terms in dy dx. Okay, but here we have 2 terms. I'm going to combine the 2. I will isolate, remove the bracket, and bring this y here as well. So let's go. I am going to maintain the 3y squared there. So I will get, okay, 3y squared dy dx maintained. Okay, I'm bringing, there's another dy term here. I'm bringing it here. And that one will give me x what? Dy dx.
Dy dx.
Okay. Then it's equal to, okay, I will maintain this one here is positive and bring this one here. So it will be y times 1, which is what? Y. Okay, then if I bring this one, this one, which is positive, I bring it here, I'm going to get minus 3s squared. All correct?
Yes, please.
Okay, so now 2 terms, you factor out your dy dx. So it means I'm going to get 3y squared minus x, the whole of that in bracket dy dx. Do you agree?
Yes, please.
Or someone can bring this one first, then put this in bracket. It's the same, multiplication is commutative. It's equal to, then this will be maintained, y minus what? 3x squared. So the next step is to write both sides again, then divide, okay, by, okay, 3y squared minus x. So I will write that step, I can draw my conclusion per experience. So therefore, my dy dx, okay, will be equal to, my numerator will be y minus 3x squared. Okay, and my denominator will be the coefficients of the dy dx there, which is what? 3y squared. Okay, minus x. All correct. Now, professors, are you with me?
Yes, please.
Okay, so you can see that in this situation, I'm going to say something very useful here. If you look at what we have here critically, when I was moving, I'm talking about this step. Okay, remember I said do your movement in such a way that you get the least number of negative terms. So if I maintain this and move this one here, I know this will be negative, so I will get 1 negative term here. If I move this one here, it will be negative, so I will equally get a negative, okay, to this side. So we have 2 negative terms, okay, after our movement. If you do your traditional movement, because traditional movements usually move to this side. Okay, again, if somebody, so we have 2 negative. So if someone wants to move to this side, the person will have this term to be negative. So 1 negative, okay, to this side. Then if you move this one, you get another negative. So you can see that each movement, okay, irrespective of the movement, you get the same number of signs in terms of negative. So the first movement gave us 2 negative signs, okay, terms. The second movement also gave us 2. So it means in this situation, any of them will be ideal. So those who did the other movement, those who moved this way, your answer will be 3x squared minus y all over x minus what? 3y squared. So let me write it here. So those who did that movement, this will be your answer. Or, okay, so if you had that answer, that doesn't mean you are wrong. You will factor out negative. So that will give us what? 3x squared minus what? Y all over, okay, x minus 3y squared. I don't know if you get my point.
Yes, please.
Okay, so any of these two would be correct. So if it's an objective question and you had this and rather you see this, you have to see that they are the same. Because if you factor out negative in the numerator, negative in the denominator, which will cancel, this becomes positive. If you factor out the negative, okay, then this becomes negative. So that's what we have here. Okay, so let me write it, maybe those. So if I factor out negative in the numerator, that will give me, okay, if I factor out this becomes negative, this becomes positive. So I write the positive first, so 3s squared, then minus what, y. All over, if I factor out negative in the denominator, okay, I will get what? This becomes positive, this becomes negative. So I write that one first, then minus 3, okay, y squared. So you know that this negative will cancel, so you end up getting what we have here. Point well made, my professors.
Yes, please.
So these two are the same expression, only that, okay, we've written it in a different form, that the meaning is the same. Okay, so now to the E. Okay, so E, which will be the last question for us. E, okay, what are we giving? Let me go and clear what we have there. Okay, it has served its purpose. But please, if you ended up getting what we have here, okay, just end here. That is, if you did this movement, this is supposed to be your answer. If you did the other movement, then this is supposed to be your answer. That's the point that I was trying to make. So you don't write the two. Don't write this or that, please. One of them will be okay if it's a subjective question. So now let's go. E, what are we giving? Y into, okay, s squared, okay, plus 1, okay, is equal to 8. All right. Okay, so now let's see what we have here. Okay, I have a product, so I'm going to take ddx of what we have there. But you can see that so far, I mean on both sides, so far, okay, we've not encountered a situation where the function that we are giving, okay, to differentiate, to find 8 dy dx, okay, involving brackets. So if you have bracket, please just remove the bracket, take it to your comfort zone before you go and apply the dy dx, or you apply, I should say, the ddx to both sides. Is my point well made?
Yes, please.
So remove bracket because you are comfortable working with no bracket. So if I remove the bracket, so in this case, I'll write, this implies that, okay, if I remove the bracket, I'll get what? Okay, x squared y plus y is equal to 8. Do you agree?
Yes, please.
So instead of giving you this straight away, which is in your comfort zone to differentiate, we factor out the y in another, then we ask you to. So now you've taken it to your comfort zone. So you come and take ddx of both sides. So you take ddx, okay, and not dy ds, so please take note. ddx of what? X squared y, okay, plus what? Y, okay, should be equal to ddx of 8. So ddx, okay, of 8. All correct, my professors?
Yes, please.
Okay, so now your differential operator here is affecting two, okay, terms, or so two-term function. So differentiate term by term. So if you differentiate the first term, you can see the first term is s squared y. So we are going to use the product rule. So that will give us dds of s squared y will be equal to s squared.
D.
You hold s squared, you differentiate y, which is plus, so that will give us dy dx.
dx.
My professors, are you following?
Yes, please.
Okay, then come and hold your y and differentiate the s squared. We've done that one, okay, already in one of the questions. So 2x, all correct.
Yes, please.
So that will be it for the differential of this term. Now you come to this term. So you are going to find ddx of y, and that will give us.
Y dx.
Come again, ddx of y.
Dy dx.
So what were you saying plenty like that? All right, okay, so dy ds. Please, do you agree?
Yes, please.
Okay, all right. So that would be equal to what? 0. So again, obviously, once we have two terms in y, we knew that we are going to get two terms in dy dx. Okay, so we are going to maintain these two terms here and move. So we are isolating the dy dx term. So I'm going to get what? X squared dy dx. Okay, then plus dy dx. Okay, then I'll multiply this and move. So that will give me minus what 2xy. Do you agree?
Yes, please.
Okay, so we are going to factor out the dy dx. So that will be the same as x squared plus 1, the whole of that in bracket, then your dy dx. Or someone can still write dy dx into, okay, so that is dy dx factored out. Okay, then into, once you bring dy dx out, then this, okay, is brought out. So in the second factor, s squared will come. Okay, then plus, okay, here the coefficient is 1, so plus 1. Okay, so the two are the same. Either you write this or you write that. I usually want to write, okay, the coefficient first before the dy dx. So that will be equal to, Prof. Daniel, I'm coming, okay? All right, minus, I want to land, okay, 2xy. Okay, you know we are going to write it again, divide okay, both sides by the s squared plus 1, the coefficient of the dy dx. So at that point, I'll get my dy dx. So therefore, dy dx, okay, will be equal to, okay, minus 2xy all over, okay, s squared plus 1. We are done. Okay, Prof. Daniel,
Sir, please, where did you get the plus y from?
the plus y.
Yes, please.
Is it this one?
Yes, please.
Oh, we expanded this, so y times s squared will give you,
Okay, sir.
you get it now, right?
Yes, please.
Okay, so welcome back. All right. Okay. So I guess the explanation is clear.
Yes, please.
Yes, please.
Okay, so okay, very good. So this will be it in terms of what the implicit function. So with all the foundation, that's all the questions that we've solved. Okay, any question at all given on implicit functions, you should be able to okay solve. Okay, looking at the questions that we've handled and all the information that you've been given, you should be able to deal with any implicit what differentiation or differentiation of any implicit what function. So this will be it, okay, in terms of what the differentiation of what implicit function. So thank you very much for your time and okay making the class very interactive.